Okay, so we've got a friend here, and he is a tailor. He makes clothes. He specializes in suits. Okay, so his goal, he says, I'm gonna make a suit that the man of average height can wear comfortably and look good. So he needs to find the man of average height, and he knows that to find the average, he needs to add up all the heights and then divide them by the number of heights that he added together. Okay, so he does that. He thinks about 3 people he knows the heights of. So he has these 3 people. He adds up their heights. He divides it by 3. His result for the average height, is 6'8". 6 feet tall, 8 plus 8 inches. Okay? So he says, I'm going to make a suit that is designed for a man who is 6 feet, 8 inches. But there's a problem. Wait. That only works for tall people, like SpongeBob when he's on stilts. Okay? Because 6'8", that's actually really tall. Way taller than me. That's like a foot taller than me. If the average person in the US, the average guy, he puts on a suit designed for someone who's 6'8", this is what he's going to look like. He's just going to have a little tiny head popping out. That's a problem. And the reason why is because the actual average of everyone in the US, every man, females it's a little different. It's actually 5'9". Okay, that's almost a foot shorter than he's making the suit for, and that's fine. But he wants the average person, so it's not okay. He might make way too many suits because there are a lot less people who are that tall. And I think with your intuition, your instincts, yeah, man, what's this guy thinking? He made a mistake. And now here are some math words that we use to talk about that. Okay? So the population is the total number of people. When I talked about basically all the men in the US, if you have their average, it's going to be much shorter than our Taylor friend found for the average. So the population is the total number of people. The sample is only the people surveyed. So he only looked at those 3 basketball players. Those were his sample. A biased sample is a sample that is unlikely to represent the population. So his example was biased. You've probably heard about bias, but maybe not in this exact way. It was biased because in basketball, it's an advantage, unless you're point guard, to be really pretty tall. So 4 out of the 5 players on the court, they're very likely to be much taller than the average person, whether that's male basketball or female basketball. And he was just making a suit for men. And that makes his sample biased. So it isn't a good example because he said that, the sample, the average of the height of these guys in the sample is 6'8". But he was so far from the population average height because he had a biased sample. A random sample is exactly what it sounds like. It's a sample where a random people are chosen. Now, if he chose random people, not just basketball players, he would have been a lot closer to the population average. Okay? So if he just said, okay, well, I'm going to choose one person from Texas and one person from California and, one totally random person from every state, he would have got a much better average. 1, because he wasn't just looking at basketball players. And 2, when you have more people, the average gets better. Okay, if you just look at one person, that's not going to be a very good average. That's just one person. But if you look at 1 million, you're going to find an accurate average, okay, for the population. So the bigger your sample is, the better. But you can't always have a huge sample, so it's best to have it as random as possible so it is not a biased sample.